Alright, I want to start by apologizing for my poor videography skills. Unfortunately, I wasn't able to figure out how to voice over or just screen record my PowerPoint. So I'm just going to be recording it with my phone, flipping through the slides, and then talking over it subsequently. So I'm Mason Wandolski. I chose to do my nutrition research video presentation over beta-alanine and the effects of supplementing with beta-alanine. The idea for this research stemmed from the research article synopsis that we also did for this class. And my proposal for that was I wanted to find foods or supplements that could help an athlete raise their lactate threshold or time to exhaustion by acting as a buffering system to the extreme acidosis buildup in the muscles during exercise. And my interest in that subject kind of stemmed from my personal life and hobbies, I guess. I'm a coach as well as an athlete at a CrossFit gym here in Denton. And so I've kind of experimented with supplements over my time of working out, but currently I'm taking a lactate supplement, which claims to do just what I said, basically provide the muscles with more energy. It will claiming that they will fatigue less fast, and basically just improve your overall performance. So all the studies I found on lactate while I was researching were very vague and kind of boring. Their data evidence was kind of inconclusive, moving from study to study, and there was much more commonality between the beta-alanine research articles I found, so that's what I chose to use for this video. So I looked at 3 different studies. I'm going to talk about each and then kind of give my concluding thoughts and overview at the end. So the first study I looked at tested beta-alanine and creatine monohydrate supplementation. The prior knowledge of this author before starting this was that the effects of beta-alanine alone or in combination with creatine monohydrate on aerobic exercise performance was unknown. And the purpose of this author's study was to examine the effects over 4 weeks of beta-alanine supplementation and creatine monohydrate supplementation, both affecting endurance performances. So the way this author set his study up was that he used 55 men split into 4 different groups. Those 4 groups were either the placebo group, the solely creatine supplementation group, the solely beta-alanine supplementation group, or the combined beta-alanine and creatine supplementation group. Both prior to and following supplementation, participants performed exercise tests on a cycle erg, which determined their VO2 max, their time to exhaustion, their power output ability, and their percent of the VO2 max associated with both the ventilatory thresholds and the lactate thresholds. Their findings were that no significant effects were observed for the groups supplementing with either one or the other, beta-alanine or creatine monohydrate or placebo. They only found a significant effect in the combined supplementation group, and in this group they found that 5 of the 8 parameters measured above had a significant time effect. So what that data basically suggests is that beta-alanine with the supplementation of creatine monohydrate could potentially enhance your endurance performance. All right. And then the second study I looked at wanted to determine or investigate the effects and effectiveness of L-histidine on and its ability to carnosine load for muscle carnosine storage. The prior knowledge of this author was that beta-alanine supplementation can induce carnosine loading and is therefore seen as the rate-limiting factor for carnosine synthesis in the muscle. A little more information why carnosine is important is because that it has been hypothesized that carnosine acts as a proton buffer, protecting the muscle from extreme acidosis, so that lactic acid buildup that I was talking about a little earlier. That is what carnosine is seen to prevent from happening. But back to this study. So they had 3 different groups, and they also supplemented with only either beta-alanine or L-histidine as well, but they also did the combined supplementation of beta-alanine and L-histidine. So at day 0, before supplementation started, at day 12, and after day 23 of supplementation, this author evaluated the carnosine content in the soleus as well as the gastrocnemius medialis through magnetic resonance spectroscopy and venous blood samples. Furthermore, muscle biopsies were taken before supplementation started, and then at day 23 from the vastus lateralis, and plasma and muscle metabolites were measured by high-performance liquid chromatography. So their results were that the beta-alanine only group and the combined beta-alanine and histidine groups both showed an increase in carnosine storage, whereas the histidine only group did not. So their findings concluded that beta-alanine was the rate-limiting precursor for carnosine synthesis in muscles, and that L-histidine is not. However, they did find that the L-histidine content in the beta-alanine only group was significantly lower than it should have been. And this author said that the effects of this decrease in histidine was undetermined as of now, but he alluded to it affecting physiological processes such as possibly protein synthesis. And thirdly, this study looked at carnosine loading and the subsequent washout of it in human skeletal muscles through beta-alanine supplementation. I apologize. This study investigated 3 different skeletal muscle types, so 3 different fiber types, the supplementation induced amplitude of carnosine synthesis, and its subsequent elimination post-supplementation. So they used 15 untrained males who supplemented for 5 to 6 weeks with 4.8 grams per day of beta-alanine or a placebo. The muscle carnosine content was quantified in the soleus, the tibialis anterior, and the medial head of the gastrocnemius through proton magnetic resonance spectroscopy. This was done before and after supplementation, as well as 9 and 3 weeks into the washout. Their findings were that beta-alanine supplementation increased carnosine content in the soleus, which is predominantly slow twitch, by 39%, and then in the tibialis by 27%, and in the gastrocnemius by 23%, both of which are more predominantly fast twitch muscles. As well as they found that carnosine levels declined post-supplementation at a rate of 2 to 4% per week. So 3 weeks following post-supplementation, there was still increased carnosine content compared to the baseline numbers taken before supplementation, and then on average, the number of carnosine content in muscles returned to the baseline values at 9 weeks. This author also took the extra mile and went ahead and compared his beta-alanine supplementation findings with creatine muscle loading. And so he found that carnosine loading is a much longer process than creatine loading. However, it can yield a much higher magnitude of storage ability and will last for a much longer time due to its washout pace. So, in conclusion, I think that beta-alanine might be an effective supplement to use to increase your endurance performance, or to increase that time to that lactic acid buildup, but it really is just going to depend on the athlete. And then my other question that I found really interesting was, what do the low levels of the histidine mean in that group that wasn't supplementing along with histidine? And does that mean that when you supplement with beta-alanine, must you supplement with histidine as well? I kind of want that answer for that question. I'm really skeptical now. And lastly, when comparing creatine versus beta-alanine, I think they are both effective as a proton buffer for those short anaerobic systems. However, I think the creatine focuses on the phosphate creatine system, obviously, whereas beta-alanine and histidine focus on that glycolytic pathway of the metabolic system. But that is my presentation for today. I hope you enjoyed it. And those are my sources, which are also listed on my article synopsis. Y'all have a good one.